Ever wondered what's beyond the sky we see every day? What mysteries does space hold? Well, let's embark on this cosmic journey together, where we'll explore the vast expanse of the universe and its enigmatic secrets. Space, my friends, is not just a black canvas filled with sparkling stars. It's an infinite expanse, so vast that we can't even comprehend its size. It's filled with galaxies, each housing billions of stars, and planets that may hold life forms we can't even imagine. And yet, despite its enormity, we know so little about it, which makes it even more intriguing. Unsolved mysteries? Oh, there are plenty. Dark matter, black holes, the concept of time and space, the existence of extraterrestrial life, and so many more that have left scientists scratching their heads in perplexity. Intrigued? I bet you are. So buckle up as we're about to blast off into this cosmic adventure. Let's dive deeper and uncover some fascinating facts about space. Silence is golden, and in space it's a universal rule. Now let's dive into why space is so eerily quiet. To understand this, we need to first unpack the concept of sound. Sound, as we perceive it, is a sensory experience created when vibrations travel through a medium like air, water, or solids, and reach our ears. These vibrations are waves of pressure that fluctuate the particles in the medium, causing them to compress and decompress in a rhythmic pattern. Our ears pick up these pressure variations and translate them into what we recognize as sound. But what happens when there's no medium for these vibrations to travel through? Well, that's where space comes into play. Contrary to what you might see in your favorite science fiction movies, there's no dramatic boom when a spaceship explodes or a meteorite crashes into an asteroid in the depths of space. Why? Because space is a vacuum, almost completely devoid of matter. In a vacuum, there are no particles to compress and decompress, no medium for sound waves to travel through. Therefore, sound as we know it cannot exist in the vast expanse of the cosmos. This lack of a medium renders space an eerily silent world. It's like being in the world's most perfect soundproof room, where not a single decibel can reach your ears. However, it's important to note that while space is silent to the human ear, it's not completely noiseless. Various space phenomena emit electromagnetic waves that, when captured by special instruments and translated into sound, can create a symphony of cosmic noise. But these sounds are not something we could hear with our naked ears. So while space might not be completely mute for all intents and purposes to us humans, it's a silent world. A world where the laws of sound as we know them hold no sway. A place where the only sound you'll hear is the one inside your own helmet. So, if you're ever in space, remember, no one can hear you scream. Ever tried catching up with your own shadow? That's how futile it would be to chase light. Picture this. You're in a race, but your opponent is faster than sound, quicker than the blink of an eye, and even outpaces time itself. Yes, we're talking about light, the fastest thing in the universe, traveling at an astonishing speed of approximately 186,000 miles per second. That's like going around the Earth's equator 7.5 times in a single second. Now imagine trying to surpass that speed. It's like trying to outpace your own shadow. It's impossible. According to the laws of physics, as we currently understand them, nothing can travel faster than light. Not your latest sports car, not even Superman. Light speed is the universe's speed limit, and it's one rule that can't be broken. But what happens if we get close to the speed of light? Well, things start to get a little strange. You've probably heard of the theory of relativity, right? One of its fascinating predictions is the phenomenon of time dilation. As you approach the speed of light, time appears to slow down for you relative to an observer at rest. To put it simply, the faster you move, the slower time passes for you. This isn't some science fiction trope, but a reality proven by numerous experiments. So, if you were traveling at light speed, you'd essentially be frozen in time from an observer's perspective. But don't get any ideas about using this as a fountain of youth. There's a catch. As you approach the speed of light, your mass increases, and so does the energy required to keep you moving. Eventually, it would take infinite energy to push you to light speed. So there's no cheating the universe's speed limit. So if you're planning a trip to the nearest star, better pack a lot of snacks. It's going to be a long journey. Imagine a canvas that keeps expanding the more you paint on it. That's our universe for you. The universe isn't a static, unchanging entity. No, It's not merely a vast expanse of galaxies and celestial bodies frozen in time and space. Instead, think of it as a dynamic living and breathing entity, constantly growing and changing with time. It's like an artist, forever working on a masterpiece, adding new galaxies, stars, and planets, and in the process expanding its canvas. This phenomenon is what scientists refer to as the expanding universe. But what exactly does this mean? It doesn't mean that the galaxies are physically moving away from each other like cars on a highway. Instead, it's the space between them that's growing. You can think of it as a loaf of raisin bread baking in the oven. As the dough rises and expands, the raisins move farther apart from each other. Similar to the raisins, galaxies are moving away from each other as space expands. This concept was first proposed by astronomer Edwin Hubble in the early 20th century. By observing distant galaxies, Hubble discovered that they were moving away from us. And the farther the galaxy, the faster it was receding. This observation led to the idea of an expanding universe. But why is the universe expanding? Well, it's due to a mysterious force we know as dark energy. This invisible energy permeates all of space and is believed to be the catalyst driving the expansion of the universe. And as it expands, the universe is also evolving. New stars are born, old ones die, and galaxies continue to form and change. The universe we see today is vastly different from the one that existed billions of years ago, and it will continue to evolve and change in the future. So, the next time you look up at the night sky, remember, you're not just looking at stars and galaxies, you're witnessing an ever-expanding, ever-evolving cosmic masterpiece in progress. And as we speak, the universe grows, just like our understanding of it. Ever looked at those fluffy clouds and wondered how heavy they could be? A cloud, especially a fluffy cotton candy-like cumulus cloud, seems light as a feather, floating effortlessly in the sky. But don't let your eyes deceive you. Believe it or not, an average cumulus cloud weighs about 1.1 million pounds, which is equivalent to around 100 elephants. Now let's take a moment to ponder about space. In space, everything seems weightless. Astronauts float around in their spacecraft, and satellites whirl around the Earth without any visible means of support. But why is that? Do they lose their mass once they leave Earth's atmosphere? Not at all. Objects in space still have mass, and therefore they still have weight. The reason they appear weightless is due to the absence of a force pulling them downwards, which we experience on Earth as gravity. In space, everything is falling toward Earth or any other body of mass at the same rate, creating the sensation of weightlessness. This is why astronauts can float around in their spacecraft even though they, and the spacecraft itself, still have mass. The spacecraft and everything in it are in a constant state of free fall toward Earth, but because they're also moving forward, they keep missing it. That's what we call orbiting. So the next time you feel heavy, remember, you'd weigh nothing in space. Space, a silent, expanding infinity where light races at unbeatable speed, and weight is just a concept. We've traversed through the enigmatic cosmos, delving into its hushed world. A realm where the only sound is the echo of distant celestial bodies whispering their ancient tales. We've marveled at the speed of light, that unfaltering cosmic sprinter, racing across the universe in a blink, defying the very concept of time itself. We ventured further into the vast expanse of the universe, an infinite canvas painted with galaxies, stars, and nebulae. A space so immense, it makes our earthly troubles seem like specks of dust in the grand cosmic scheme. An infinity that humbles us, reminding us of our place in the cosmos. We've also explored the weight of a cloud, how it's merely a concept in the absence of gravity. A nebulous entity floating in the sky, defying the very laws that govern our earthly existence. But this is merely the tip of the cosmic iceberg. There's so much we don't know, so much more to explore. Every discovery opens up a new realm of questions, making us realize that our understanding of the universe is but a grain of sand on the cosmic beach. As we continue to unravel the mysteries of space, remember it's a journey, not a destination.